Good evening, class. So today our topic is matrices. Starting with the first question. So, part want to try it? Our first question is: given that the A matrix and B matrix are given, and all the options are related to A, B, and BA. So first of all, we need to find AB. So that would be A and first row, second column 2B, 3A, and 4B. And BA will be A00B 1, 2, 3, 4. So that would be A 2A 3B and 4B. So if AB equals to BA, then we can see that 2B and 2A should be equal. That is 3A 3B, that is A equals to B. For A equals to B, this is possible that AB will be equals to BA. So the options are: first one is there cannot exist B such that AB equals to B. No, not correct. There exists more than one but finite number of B's. No, A and B can have any values, but though two values should be equal, so there exists infinitely many B's for which AB will be equals to B. So the correct option is option D. This is the first question, Arushi. So moving to the next question. Okay, giving you 30-second time. Okay. So we are given that A equals to determinant value of A is given. Actually, that must be a not a determinant, that is a matrix. And if determinant value of A square is 25, then alpha equals to. First of all, we need to find matrix A into A. So on multiplication, that is first row, first column, you will be getting 25. First row, second column, 25 alpha square. Okay, that will be 25 alpha plus 5 alpha square. And first row, third column, that will be 5 alpha plus 25 alpha square plus 5 alpha. So that will be 10 alpha plus 25 alpha square. And second will be 0, 0, 0, 0 alpha square, 0, 0, 5 alpha square, and 25 alpha. Third row, first column, that will be 0, 0, 0, 0, 0, 0, and that will be 25. So if we'll try to find the determinant value of this, then it will be 25 into alpha square minus 25 equals to 0. So alpha square equals to 25. So alpha is equals to mod of 5. So alpha will be equals to plus minus 5. Sorry, mod of 5. So it will be 5. Or mod of alpha, we can say it will be equals to 5. So correct option is D. Did a spelling mistake? I mean calculation mistake. Okay, that's good. Let's move to the next question. Giving you 30-second time. So we are given A and B are two symmetric matrices of order 3. Statement 1 is A, BA and ABA are symmetric matrices. Statement 2 is AB symmetric matrix if matrix multiplication of A with B is commutative. So A and B are symmetric matrix, that is A transpose will be equals to A and B transpose will be equals to B. Now let's go for ABA. Let's say this is some matrix C. So C transpose will be ABA whole transpose. Now, if you are doing multiplication of ABA, then it is associative, that is AB into A whole transpose. So we know that from the property of transpose, X into Y transpose is equals to Y transpose into X transpose. So this will be A transpose into AB transpose. So that will be A transpose and AB transpose will be B transpose A transpose. Now since it is given that A transpose equals to A and B transpose equals to B because they are symmetric, so this implies that it will be equals to ABA. So we can see that C transpose is equals to C. So ABA is a symmetric matrix. So our statement 1 is true. Now moving to the second statement. Our second statement is AB is a symmetric matrix if matrix multiplication with of A with B is commutative. So if we will take AB whole transpose, then it will be B transpose into A transpose. B transpose will be B and A transpose will be A. It is given that AB multiplication is commutative, that is AB will be equals to BA. So this will be equals to AB. So yeah, this statement is true. So we can see that the statement 1 and statement 2 both are true. So the correct option is option B. Moving to the next question. Let A equals to 1, 0, 0, 2, 1, 0 and 3, 2, 1 and U1 and U2 are the column matrices such that multiplication of A with U1 and multiplication of A with U2 is given. Then we need to find the value of U1 plus U2. Try it 30-second times. So how we are going to do is u1 and u2 are column matrices. Let's say matrix u1 is a1 b1 c1 and u2 is a2 b2 c2. Now a into u1 will be 1 0 0 2 1 0 3 2 1 and a1 b1 c1. It is given that its value is 1 0 0. So on solving this, first row first column will give you a1 2a1 plus b1, and this will be a1 2a1 plus b1 and 3a1 plus 2b1 plus c1 is equals to 1 0 0. So from this we can see that a1 is equals to 1. If you will put a1 equals to 1 here, you will get b1 equals to minus 2. And if you will put these two values here, you can find the value of c, that is 3 minus 4 plus c1 equals to 0. So c1 will be equals to 1. So our u1 is 1 minus 2 1. For u2, it is given that a u2 is 0 1 0. So A's are 1 0 0, 2 1 0 and 3 2 1, and U2 is A2 B2 C2, and this value is 0 1 0. So this is A1 2A2 plus B2 and 3A2 plus B2 plus 2B2 plus C2 is equals to 0 1 0. So from this A2 is 0 and B2 is equals to 1 and A2 0, B2 1. So C2 is minus 2. So on adding 1 plus 0 we'll be getting 1. So U1 plus U2 give you 1 minus 1 and 1 minus 2 minus 1. So the correct option is D. So our answer is D. That's good. Moving to the next question. We have to find the solution of this equation. Okay, by matrix method, we know that if we are having Ax equals to B, then we find x equals to, or we can say we multiply both sides by A inverse on left side. So A inverse of Ax will be equals to A inverse of B. So that will be A inverse A into X is equals to A inverse B, and A inverse into A is I. So this implies X is equals to A inverse B. So first of all, we have to find the inverse of A, and then we have to multiply it with B, and then we can find the values of X, Y, and Z. Or what you can do is, you can write the equations directly. So the equation will be X plus Z will be equals to 1 minus X plus Y plus 0 into Z is equals to 1 and minus Y plus Z equals to 2. And easily you can see which all options are satisfying it. So from this, if you look at the options, if you put x1 and y1, so not possible. X minus 1, y0, this might be possible, but z is equals to 2. So B, these two equations are satisfied. Now checking for this one, this is also satisfied. So B is the correct option. Okay. Moving to the next one. So discuss for the values of lambda the system of equations as regarded as existent and the nature of solutions. Okay, we can find the discrete value 1 1 4 1 2 2 and lambda 1 1. So this should be not equals to 0 for unique solution. So let's check it. So what we are getting from here is 1 into minus 1 into 1 minus 4 plus lambda into 1 into this is cool minus 1 into 1 minus 4 plus lambda into 2 minus 8. So we are having minus 1 into minus 3, that will be plus 3 minus 6 lambda should not be 0. So lambda should not be equals to 1 by 2 for a unique solution. So C is our correct option. Got it? See, we are having this equation a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z equals to d3. Then for unique solution, let's write the determinant value a1 b1 c1, a2 b2 c2, a3 b3 c3. So for unique solution, a should not be equals to 0. For infinite solutions, a can be equals to 0 and d1, d2, d3 should also equals to 0. D1, d2, d3 from the Cramer's rule. Okay, so d1 will be replace the values of coefficients of x by d1, d2, d3. So that will be d1, b1, c1, d2, b2, c2, and d3, b3, c3. Similarly, you can find d2 and d3. And for no solution, a is equals to 0, but d1, d2, d3, at least one is non-zero. Okay, so this is one method. And the other method is you can find it by the rank. Okay, so basically what is a rank? If you need to find the rank of a matrix, then it is the smallest determinant non-zero value. So how we can do it by the rank is, we have written ax equals to b in the matrix form. So we are having matrix A and matrix B. So we will define a matrix C, which is A, and we have written colon so that we are writing the values of these constants in here. So we are having a new matrix C, which is the combination from A and B. So 1 1 4 6 and 1 2 2 6 lambda 1 1 6. Okay, this line is just for the presentation basis. This is a simple 3 cross 4 matrix, 3 rows and 4 columns. Okay, now we have to find the rank of the matrix. So to find the rank of the matrix, we have to write it in the Euclidean form. So to write it in the Euclidean form, what we are going to do is we are trying to make zeros in the third row. Okay, so how can we make the zeros in the third row is, we have applied this operation in R3, 2 times of R3 minus R2. So if we will multiply it by 2, so this will be 2 lambda, 2, 2 and 12. And if you subtract it from R2, then this will be 2 lambda minus 1. 2 minus 2 will be 0, 2 minus 2 will be 0, and 12 minus 6 will be 6. So we will get this one. Okay. Now, trying to make this 1 0. So subtracting these two, it is 0, 0. Now, for unique solution, rank of A should be equals to rank of AB. And for infinite solutions, rank of A should be equals to rank of AB, but this rank should be less than the number of rows. Here the number of rows are 3. Okay. And for no solution or inconsistent, rank of A should be less than rank of AB. So these are the three conditions. Okay. Now how to check for the rank is, here if you'll see, then this part, or after this operation, this part is our A and this C is our A and this line B. Okay. So if the rank of A and rank of C both are equals to 3, it should be equals to number of rows. Then they have a unique solution. So rank of A should be 3. That means this cannot be equals to 0. If this value is 0, this row is 0, then the largest determinant which will be having non-zero value will be of 2 cross 2. So rank would be 2. So to get the rank 3, 2 lambda minus 1 should not be equals to 0. So we will get lambda is not equals to 1 by 2. Obviously, if this is not 0, then this row won't be 0. And this is obviously not 0 and not 0. So the rank of C will be 3. So the condition will be lambda equals to, lambda should not be equals to 1 by 2 if this should have a unique solution. Clear? Is this a new concept to you? Let's do it one more time. Okay. So how we are going to find whether with the system of equations will have a consistent unique solutions, infinite solutions, or no solution is, we have to use the method of rank. uh, okay, this was the Cramer's rule and I am writing this rank method in here. You all know Cramer's rule? Okay, that's good. So from the method of rank, how we are going to do is, we are having Ax equals to B. Obviously X is of 3 cross 3 most of the cases and B is 3 cross 1. So we have to find, first of all, make a new matrix C from the combination of A and B. So write it all the 3 cross 3 and this is 3 cross 1. So C will be a new matrix of order 3 cross 4. Now what we are going to do is, we are going to write it in the equivalent form. And what do you mean by an equivalent form is, if we are having this, let's say A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. To find the rank, we will try to hit the third row first. For third row, we will apply any operation so that we can make these all elements 0. Okay, if we will make all these 0, and we are having A1, A2, A3, A4, B1, B2, B3, B4. So the rank of A will be 2 and rank of the C will be also 2, because the smallest, the largest determinant of non-zero value. See, बेसिकली ऐसा करना है कि हमको क्या करना है, हमको एक डिटर्मिनेंट वैल्यू फाइंड करनी है। हमको देखना है कि सबसे बड़ा क्या डिटर्मिनेंट वैल्यू होती है जो नॉन जीरो। अगर C1, C2, C3, C4 में से मेरे पास मान लेते हैं C2 नॉन जीरो आ गया, ओके, सो हमारे पास क्या हो जाएगा कि C2 नॉन जीरो आ गया, तो हम यहाँ देखेंगे तो कोई भी हमको 3/3 का एक भी डिटर्मिनेंट नहीं मिल रहा जो कि जीरो हो। ये वाला भी नहीं है, ये भी नहीं है। ओके, सो हमारे पास जो रैंक हो जाएगी वो 3 हो जाएगी। इज इट क्लियर? नाउ if we are having this value C1 and all these are 0, so this will be 0, but there will be at least one determinant, this determinant, which is of 3 cross 3 and which is non-zero. So again the rank will be 3. Okay, now if this is 0, then in no case you can find a 3 cross 3 determinant which will be 0. So we will try to hit for rank 2. We will check whether the rank can be 2 or not. So for rank 2, again we will put some operation in R2 and we will try to make all these elements 0. If we will get all these 0, then rank is not 2, rank is 1. And if we will get at least one value, let's say this is non-zero, then we will be having this determinant, at least one determinant of order 2 cross 2, which is non-zero, so rank will be 2. Is it clear now? So we are taking an example of 3 cross 3 because you can get a matrix value of 4 cross 4 also to find the rank. You can get any matrix to find the rank. Okay, so what we have done here is, again I am explaining you this whole thing. So, not explain this. Write this concept. Huh? So what we did here is, we were having the system of equations, we wrote it in the form of matrix. So we are having matrix A and matrix B. Now we have defined a new matrix C such that we have defined it, this column is just for the representation purpose, that we are having A and B together written. Now for this matrix C, we will try to find the rank. How to find the rank? First we will head third row. So we have seen that there are these two values 1 and which can be made 0 with the operation if I will multiply the third row by 2 and subtract it from the second row. Okay, so what we did is multiplied this third row by 2 and subtracted it from the second row. So we got this. Now no other operations can bring more zeros in third row. If you will try to say that this 6 and 6 or this 6 and 6, but if you will try to make this 0, then these two will become non-zero. This will be obviously be a quantity which we don't know, 0 or non-zero, depending upon the value of lambda. So there is no other operation we can put in the row 3. So row 3 is cool here. Now let's hit for row 2, trying to make zeros in there. So if we will subtract directly row 2 by row 1, we will get these two zeros. or if you will multiply it by 2 and then subtract, then you will get only 1 0. So we will try to get maximum number of 0. So we got here 2 zeros. Now again we are having no other operation by which we can make maximum or more zeros. Is it clear till this one? Okay. Now for unique solution. So what is the condition for unique solution? Rank of A. What is A? This whole part is our A. So rank of A should be equals to number of rows and rank of C should be equals to the number of rows. How many rows we are having? 3 rows, or we can say 3 equations. That is the number of equations. So for this value to have rank 3, this quantity should be non-zero. So 2 lambda minus 1 should be non-zero. So 2 lambda minus 1 is not equals to 0. So lambda is not equals to 1 by 2. To check for C, obviously this is a non-zero determinant value. So if this is a non-zero determinant value, then we can see that C is already having the rank 3, irrespective of the value of lambda. But A will have rank 3 only if this lambda is not equals to 1 by 2. Got it? Okay. So moving to the next question. Try this question. So we are given, using the matrix method, find the values of lambda and mu so that the system of equation has infinite solution. Now A we can write 2 minus 3 5, 3 1 lambda 1 minus 7 8, and B we can write 12 mu 17. Now C we can form 2 minus 3 5 12. Okay, see, that will be in the solution. Let me tell you how to do it by Cramer's rule. So first of all, we are having infinite solution. So determinant value of A should not be equals to 0, or determinant value of A should be equals to 0. That is 2 minus 3 5, 3 1 lambda 1 minus 7 8 should be 0. So from here what we will get is on solving 5 into minus 21 minus 1 minus lambda into minus 14 plus 3 plus 8 into 2 plus 9 equals to 0. See here, this value is 11. This is minus 11. Minus we can take out. So this will be 11. This is 22. So we are having minus 5 into 22 plus lambda into 11 plus 8 into 11 equals to 0. So 11, 11, 11 minus 10 plus 8 plus lambda equals to 0. So lambda equals to 2. So lambda is equals to 2. Now let's move for any of the one quantity, let's say d1. D1 we will be having 12 mu 17 minus 3 5 and 1. In place of lambda we are having 2 minus 7 8. So let's find the value of d1. So d1 will be 12 into 8 plus 14 minus mu into that's going minus 24 plus 35 and plus 17 into minus 6 minus 5. So this quantity is 22, this is 11, this is again 11, negative sign outside. So 11, 11, 11 this, so 24 minus mu minus 17. So mu will be equals to, see d1 is equals to 0, so mu will be equals to 7. So the correct option we are having here is B. Okay. So this is how you will solve it by oh they are correct. R2 will be mu 1 lambda and lambda is equals to 2. Okay. So from Cramer's rule you will get this is the option. Now let's see from the matrix method. So we wrote C. Now we will try to make zeros in here. So what we did is first of all R1 minus R2 minus R3. So we got this. Again in R2 we applied one more operation and in R3 we applied the operation. See, you have to apply any number of operations so that you can get some simple values. Okay, or make maximum number of zeros. So for this zeros, so in R1 we applied, you can apply the other operations also. Okay, don't you have to go for this series only. This is just like in the determinants, you apply the operations, different operations, but you will get the same result. Okay. So here what we are doing is, here we are applying the operation in R1, R2 minus R1. So we are subtracting it, we will be getting 1. Why we are getting 1 here? So that 1 minus 1 will be 0. Okay. Now again in R2 we applied the operation R2 minus 3R1 so that this will become 0 and the other elements will change likewise. Now in this we will put R3 minus R1 so that this can become 0. So we will get this. Now we can see here that we are having one more possibility to make this value 0. So we applied in R3, R3 minus R2. So we are getting this 0. Now this is our A. So we need infinite many solution. So what we need, the rank of A should not be equals to 3. It should be less than 3. So how can it be less than 3? So this value should be 0. That is lambda minus 2 should be equals to 0. So lambda will be equals to 2. Then A will be like this and its rank will be 2. Now for C also we need the rank to be 2. So 2 rank we can get if we will get this whole row 0 and this whole row will be 0 when 7 minus mu will be equals to 0. So mu will be equals to 7. So you are having two different methods by which you can solve it. Clear? Moving to the next question. Now, solve the following system of linear equations. It must not take more than 20 seconds. Because how we are going to solve it is, look, first of all, we will be going by options. By first option, x is 2, y is 2, z is minus 2. So this value will be negative, this will be negative, and x equals to 2, that is 4. So 4 subtracted by some values cannot give us 8. So option A is not the correct option. Let's go to the second option. X is negative, y into minus 1 will be negative, z is negative. Obviously, three negative values cannot give us answer 8, so B is not the correct option. Let's go for the option C. So for option C, minus 4 plus 2 minus 6. Not a negative value, so option C is not the correct option. So option D is the correct option. Clear? Or otherwise you can solve it by the matrix method. Now moving to the next question. In the following system of equations, a minus tx plus by plus cz equals to 0, bx plus c minus ty plus az equals to 0, cx plus ay plus b minus tz equals to 0 has non-trivial solutions for different values of t, then the product of the different values of t is. So what we will be having here is all these values are 0. So it is said that they have non-trivial solutions. So for non-trivial solutions, the determinant value of all the coefficients will be equals to 0. So that will be a minus t b c b c minus t a c a b minus t equals to 0. On solving this equation, you will get a cubic equation in t. So already solved. So you will get a cubic equation in t. Now we are asked that then the product of the different values of t. Since it is a cubic equation in t, it will be having the three roots t1, t2, t3, and from the basic knowledge of cubic equation, we know that the product of all the roots will be equals to minus d upon a. So this will be equals to minus of d is this quantity taking minus sign common, a cube plus b cube plus c cube minus 3abc upon a, that is minus 1. So the answer is option number A. You must know this thing, okay? That this determinant, this value we obtained from the determinant value ABC, 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 okay? Or this. Now moving to the next question. Okay, this is something you will get using the matrix method. Find the value of lambda and mu so that the system of equation has no solution. Okay, if we will be going by Cramer's rule, then for no solution, again determinant value of a is equals to 0, and any one of that determinant value will be non-zero. So d1 will be non-zero, or d2 or d3, d4. Okay, so either solve it by that method or by the method we have just run. So we will find the c in here, then we will apply the operation. See, this is the same one, so we will apply the operations and get the same matrix C. Okay, we are just going through the other concept of no solution. So for no solution, rank of A should be less than rank of A by B. So rank of A less than this, so rank of A should be 2. So for rank of A to be 2, lambda should be equals to 2. And if mu is equals to 7, then rank of C will be 2. But we want the rank of C to be greater than the rank of A. This implies that mu is not equals to 7. Is it clear? Okay, this is the same question. Now moving to the next question. If A is a matrix in terms of alpha and beta, cos alpha, sin alpha 0, minus sin alpha, cos alpha 0, and 0, 0, e to the power beta, then A transpose will be cos alpha sin alpha 0. First row will be turned into first row will be turned into first column, second row will be turned into second column, and third row will be turned into third column. Sir, it is a multiple choice question. So from A transpose we can see that obviously cos alpha and cos of minus alpha are same. Sin alpha is minus of sin alpha 0. Again minus of sin alpha, cos of minus alpha 0, and 0, 0, e to the power beta. So we can see that A alpha beta is same as A negative of alpha and beta. So option A is correct. Let's go for option B. For option B, if you are having this thing, let's find A of alpha beta into A of minus alpha minus beta. If that will be equals to I, then this will be inverse of this. So A of alpha beta is cos alpha sin alpha 0 and minus sin alpha cos alpha 0 and 0, 0, e to the power beta. And this value will be cos minus alpha is cos alpha, sin minus alpha is minus sin alpha 0. This will be minus of minus, so plus sin alpha cos alpha 0 and 0, 0, e to the power minus beta. So on multiplication, first row and first column, we will be getting cos square alpha plus sin square alpha 1. First row, second column, cos minus sin cos, that will be 0. This will be 0. Then second row, first column, so minus plus plus plus, so that will be 0. This minus into minus plus sin square alpha plus cos square alpha 1. This will be 0. Again 0, 0, 0. This will be 0, and 0, 0, e to the power beta and e to the power minus beta will be e to the power 0, that is 1. So these are inverse of each other. So B is the correct option. Obviously A was correct and D is not correct. Now let's check for C. So for adjoint we need to find, see, for adjoint we have this property, adjoint of A is equals to determinant value of A into A inverse. Since A inverse is equals to this, we have to just find the value of determinant value of A. So determinant value of A is cos alpha into this minus 0. or we should open it from column 3. So 0, 0, and for beta, this will be cos square alpha minus of minus plus sine square alpha. So this determinant value will be e to the power beta. Okay. So that should be e to the power beta for the answer. C is given as answer, but might be a misprinting here. If it is plus e to the power beta, then C is the correct option. Got it? Always remember these basic properties. You don't have to find adjoint A by using cofactors if you are already knowing A inverse. For A inverse by objective method, always remember if you are having some option in which you have to prove that A inverse equals to this value in A or B, then multiply those two matrices. If you are getting an identity matrix, then it's cool. Okay, let's move to the next question. Okay, this question you might have proved it in the NCERT. So there it was given that A equals to this, you have to show that LHS equals to RHS. But here in objective, what we are going to do here is we are having no boundation for the value of alpha. Let's put alpha equals to pi by 2. So this implies that alpha by 4 will be equals to alpha by 2 will be equals to pi by 4. So our A will be equals to 0 minus 1 1 0. Now we are having I plus A. I is 1 0 0 1. So I plus A is 1 minus 1 1 1. Let's check for what all options are giving us this value. So first one is we need to find I minus A. So I minus A will be 1 1 minus 1 and 1. And cos alpha cos pi by 2 minus is 1 and 0. If I am going for option C. Then if we will multiply it, then 1 into this 1 into this will be 1. First row second column it will be minus 1, 0 and 1, this will be 1 and this value will be 1. Okay, so option number C is correct. Okay, and for A and B, if you will put this 0 1 minus 1 and 0, if you will multiply, obviously, because if you are having this first row and first column, then it will be multiplied by minus 1, means 1 into minus 1. This quantity will give us a value minus 1 and we are having here value 1. So this cannot be the option and this cannot be option. So our correct options are C and D. Just check for the one element. If that one element is cool, then we will go for the other elements. Here we can see that for this element, if we are having I minus A is 1 and 1, we have to multiply it with the first column which give us value 1. So first row, first column, we are getting value 1. Here, if we are multiplying it by the first column 0 and minus 1, so 0 into 1 is 0 and 1 into minus 1 is minus 1. So this is not the correct option. Here again, if you will see, then the first column is 0 and minus 1. Again, 1 into 1, 0 is 0 and minus, and 1 into minus 1 is minus 1. Again, we are not getting 1 here. So these two are not the correct options. Clear? Now, moving to the next one. It is given that A is equals to, okay, so times up, try it yourself. Okay, let me tell you the answers. The correct options are B and C, and easily you can find the adjoint by finding the cofactors. Most of the elements are 0, and for A inverse, again you can find it easily because you will be having the value of adjoint A, and the determinant value of A will be 0 into this, 0 into this, 1 into, so a determinant value will be equals to -1. Okay, goodbye class, thank you.